Bismillahirrahmanirrahim. In this video, we are going to introduce the concept of functions in programming languages, particularly for the programming language that we are considering, that is the C++ language. So the outline of this topic is as follows. We start with the introduction, we give the program components, we define some of the built-in functions, and then later on we are going to consider our own functions, the prototypes, how we can pass values to them, how we can pass variables, how we can return data type from them, and a lot of other things as we can see from this list. So inline functions, references, default arguments, and a lot of other stuff. So let's start with the beginning. What exactly is a function and why do we need these functions? So functions were developed in order to facilitate us during the programming to break down the task that we are trying to program into smaller tasks and then use what is known as the divide and conquer strategy. The divide and conquer strategy means that if you have a complex problem, you divide it into sub-problems, solve the sub-problems, recombine so that you can solve the original problem. And the advantage of that is when you divide it into sub-problems, then the sub-problems are easier to solve, and then you can use those solutions to the sub-problems and reconstruct the solution to the original problem. Now let's look at an example. Let me put my pen. Okay, we have a pen. Right. So suppose I want to just find using the Pythagorean theorem. Excuse my drawing. Oh. So let me call this C, let me call this A, and let me call this B. Now we all know that C square is equal to A square plus B square, and therefore C is equal to A square plus B square under root. Now if you look at this problem and I ask you from a programming language point of view to solve for C, so you can see that you need, first of all, you need the values of A and B, then you need to square them, then you need to sum them, and you need to take the under root. Now we can look at this as a complex problem. Why? Because there are certain number of steps that you need to take. So the way to I can do that, if I have to write everything, then instead of concentrating on my Pythagorean theorem, what I will be busy doing is finding out how I can find the squares and how I can find the under root. So instead of that, I can say, okay, finding C, this problem can be divided into let's say 3 parts. First of all, you can take the inputs from the user. So what we are talking about the values of A and B. We can take those inputs from the user. Now that's one task. The second task is finding the square and adding. So, and the third task can be finding the square root of the problem. So now this finding the value of C has been divided into 3 subtasks. So I can, first of all, I have to take the input from the users, the values of A and B, and then square them and add them, and finally take the square root of the resulting value. So if I want, I can, subdivide this into, or I can, instead of coding the entire thing in the main of my program, I can use what are known as functions. So I can develop a function that take inputs. I can develop another function that take squares, and I can develop another function that take square roots. Now by doing that in my main program, I will just be calling these 3 steps, and I'm not bothered about how the inputs are being taken, how the values are being squared, or how the square root is being taken. My concentration over here is I have to follow these 3 steps, and the advantage of that is that once I develop, for instance, using a function, I develop how to take a square root, then I can reuse that again and again every time I want. So in this example, I'm trying to find the this value of C in this right angle triangle, Maybe in another case I'm trying to solve for a quadratic equation. In that case also I have to take a square root. So but if I have a function over here such that if I give it a value and then it just returns me what's the square root, and similarly there's a function, if I give it the value it gives me the square, so I can reuse whatever code I have written here for my other problem, that is using the quadratic formula. So that's the main idea of developing functions. You develop functions that will perform subtasks, and you spend your time on that. You make sure they are accurate, and then you give them a name, and then every time you need to use them you just simply call that from your main function. So that's the whole idea of having functions and the divide and conquer strategy. Now there are different kinds of functions. Some of the popular functions are already given in C++. So they come pre-packaged in the standard C++ library. What I mean by pre-packaged is that someone who is developing the C software, they did that task for you. You don't have to do it yourself. So things like input, output, the get line, C in, C out. C in, C out are not exactly functions, but get line and read are functions. And then the common mathematical calculations, for instance, the power, the square root, the exponent, and these are all commonly used functions that somebody has already written into the standard C++ library. What's this library? If you remember, you have been using hash include and iostream. Now this iostream is a header file. This is known as a header file, and it contains things like how to treat C in and C out, and somebody has written that. They're not functions, they are called operators, but somebody has written them. The concept is the same, and to be able to use these functions you need to include, so this is going to be hash include and cmath. So if you include cmath, you have a whole list of functions that, for instance, power, square root, exponent, you can calculate all those things. You don't have to write the code for that, and you can concentrate on whatever you are doing. So to be able to use any of these functions, you must first include the header file in which they are placed. So these are known as built-in functions because they're already there. But you don't have to use the built-in functions, you can even create your own. For instance, if there is no built-in function for whatever you're trying to do, you can create your own one. And this is for the string manipulation. So for this you have to include the C string header file. So functions are invoked by a function call, and so in the main, to be able to do that subtask that a function will perform, you will have to call that function by its name. Now it may have some parameters, and it may also have a return type, or it may not. And the analogy is like a boss is to a worker. So the boss, or that's the main function. It's also, in fact, main is also a function. If you recall, we've been writing int main with this bracket, and write whatever code we want. So this main itself is a function. So this is a function. What it tells us is that it's a function, its name is main, it does not take any parameter as input, and it returns something that is of data type integer, and that something that will be returned is, if you recall, we usually write return a 0 at the end, and we have discussed this several times in the class that return 0 means if the value of 0 is returned, it means the main function executed successfully, there was nothing wrong. If something is wrong over here, for instance, I do a divide by 0, and then the function main will abruptly stop, it will return, and it will return with the value of 1. So the compiler, the software that's running this, will know whether the complete function was executed or whether it stopped somewhere in the middle without performing all the tasks. So the boss here is the main function. It asks a worker or the called function to perform a task and return the value. So for instance, if you in the main you are saying maybe cout and sqrt of 100. So basically the main function is asking a function called sqrt, which is included in the cmath library. So you have to include cmath, and it's asking that to calculate the square root of 100 for it. So main is the boss. It's asking the worker, and the worker is the sqrt function, and it's sending it the value 100, saying please calculate the value of 100 for me. So calculate the value and give me back the answer. And that, the square root is given the value 100, it returns, and whatever it returns is printed in the cout statement. So the idea here, as I said before, is that the function is written once and it can be used many times. And these statements are hidden from other functions. So whatever is inside one function is hidden from another function, including the main function. Main is also a function. It's just the boss function. It's the master function, because the control of the program goes to main. So as we discussed, math.h or cmath, math.h was the previous way of writing it, and the newer way of writing it is cmath. So instead of including math.h, you will just include cmath. So the way to call a function or write a function is the function name, the arguments, and sometimes we also have the return type. So this is just the example we were looking at previously. Cout sqrt 900.0. So it means that the value being assigned or being passed to this square root function is a real value. So it can be a float or a double value. So in fact, it's a float value. So 900.0, it means that the return type is also going to be something which is a float or a double. So the sqrt function takes an argument of type double and returns a result of type double, as do all functions in the math library. So all the functions that are pre-included in this file math.h take the value as double and return is as double. You don't have to, even if your 900 was not double, if you pass it. So we looked at in the previous one of the previous lectures, we looked at what is called typecasting. So if you pass an integer, it means that the integer will be upgraded to type double, which is easy to do since integer has a smaller number of bytes and double has a larger number of bytes. You can go from smaller to higher, but you cannot go the other way around without being sure that you don't lose any information. So the function arguments can be for instance square root of 4, where 4 is a constant. You can have a variable x, square root of x, it will give you a value, and you can even have an expression. So this square root has an expression which is a function called itself. So this is a nested function. So if I, for instance, if I write, if x is int x is equal to let's say 10,000. So when I call this is basically saying square root of 10,000.0. Why 0.0? Because all the functions in a math library are of type double. So when I pass it as an integer 10,000, it will could be converted into a double and 10,000.0. So, and then we are going to calculate the first or the inner one, and so this will be sqrt of, so the square root of 10,000 is 100. So this will become a square root of 100, which will then become 10. So if I'm going to write cout this thing, then the output will be 10, because this is first going to be computed, which will form the input argument of the second call, and then the value given here is 10. So similarly over here, if this was 3 minus 6 into x, this is not exactly C++, this is a mathematical equation. If it was C++, it would have been C asterisk x. So functions, they allow the programmer to modularize a program. They have local variables and they take input parameters. So a variable inside a function, since a function will be defined by a block, so all the variables inside that block are local variables. If you recall, we had a detailed set of examples about the scope, and we said that anything that is in a block here is a local variable. So if I have int I is equal to 2 over here, and here I write cout I, this cannot happen because this is outside of the block. I would be unidentified here. Unidentified variable over here, because this is only defined inside of this block. If however we had an int I is equal to 3, then yes, in this case this will work and it will give us an output of 3. So this is the same for functions, because functions will also be limited by these two bases. So in the case of a function, all the variables that are defined inside a function are known as local variables. So they are only known in the function in which they are defined. And all variables declared in function definitions are local variables. And the second type of variable that you can have in a function is known as the parameters. Now local variables passed when the function is called, that provide the function with outside information. So if I call sq, excuse me, oops, let me write it here, sqrt of 100. Now this 100 is being provided by an outside function. So if I'm calling this inside the main, it means the main is providing this 100, and it's not a variable that's defined inside this bracket. It is being provided by an outside source. This is known as a parameter. So let's look at how the function definition looks like. So a function may take an input, perform operations, and return the result. So these two are optional, taking the data and returning the result. If you don't take any data, you leave the brackets empty, and if you don't return a result, you replace this by the keyword void. But we'll see that in a few examples as we go on. So let's look at this example, how the function looks like. Now here you can see that we defined a function. The name of the function is square. So anytime you want this function, so if you remember, we had this boss and worker analogy. So anytime the boss wants to order the worker, it will call the worker by its name. It will say square and then give it a value y of type integer. So in the math we saw that it is of type double because that was the default value. If you're defining your own function, in this case we are defining our own function. We can choose any value we want as an input, and we can choose any value we want as the output. So square is the name of the function. This is the name of the function. So name of function. This here is the input parameter. It is also sometimes known as an argument. So the input value. This is the data type of the input parameter or argument. This here is the data type of return value. This here is the processing being done. So it takes an input, performs an operation, and return the result. This is the processing being done. So performing operation, processing, or operations that are being done. And this here is what is going to be returned. So the value returned here, this is going to be assigned of this data type and returned. So in this case we have the function whose name is square, takes one argument or one parameter whose name is y of type integer, performs this operation y into y and returns the result which is also an integer. So if I have my int main over here, and here I have int x is equal to 10, and then cout square of x and return 0. This is my main function. Here I define x is equal to 10, and then I pass, so this is the boss, the main is the boss. It's calling this square function here, the name is the same. It's passing this value x, so the value of x will now go and be copied into y. So first of all I have to define also this. So where does this entire thing goes? It goes somewhere here. I have int square and int y, then return y into y and this. So as soon as the program, here I have the hash include and other things using namespace. So as soon as the program is executed, the control goes to main. You say okay, x is equal to 10, so you have here x is a box, its value is 10, and then you find there's a function call. So the function the control is transferred to the function named square. This is the function named squared. It has a parameter called y. So here we have something called y, and the value being passed here is x. So this x goes into this y. So x was 10, y also becomes 10, and now the control is with square. It will find y into y, so this will be executed. This becomes 100. So 10 into 10 is 100, and this value will be returned of type integer into this. So the cout here will be 100. That's how it works. Now the function has finished, and the transfer will be returned back to main. So the next statement after this function call will be executed. In fact, this statement first will be executed because we have to see out this. So this will be executed when the function is called. Transfer goes to this function. It executes whenever it finds either return or this brace ending braces. It will return to the point from where the function was called in the first place. So it will return the value 100. It will be cout, and then the next statements will be executed. So that's how the function works. Here we have the example in a written form, in a typed form. So in this case you can see that since, for instance, here before I use x, I have to define what is x. Otherwise the compiler will complain saying I don't know what x is. So we have to either declare or define. If you remember, declaring was just saying int equal to x, and defining is saying int x and then assigning a value for it. So in this case I defined the function square, and I declared the function square, and at the same time I defined it, what it does. So the function itself here is written. In this example, this is a function declaration. So this here is declaring a function. It means that you're telling the compiler there is going to be a function whose name is square. It takes input of type integer and it returns a value of type integer. This here is known as a function prototype. It means it is telling the program how a function will look like. But the actual definition of the function comes much later after the main. So you repeat this, but here you add that the integer value that is being input here is called y, and you return this. So this is the analogy here is the same as when you're writing int x is equal to 10. So this is one way of writing it, or you write int x and then x is equal to 10. So the way I did it over here, so I define square, I declare square, and I define it at the same time. This is this way of writing things. And in this one, the example in the book, you have a prototype over here, and then the actual definition comes much later. So this is this way of writing things. So either you can choose this or this. Normally we don't write the entire things over here, we just write the prototypes and then we let the definition, because most people are interested in the main rather than what the function does. So I don't want to start my program and the main will come much later. Instead what I do is I just write the prototypes over here so that the compiler knows that there is a function called square, takes an integer, returns an integer. That's it. And then it goes to the main, and then when the function is called, you actually go to the you search, because you already know that there is a function named square. You go looking for that function, you find it over here, and then you can see what it does. So it is the same as either using this form or this form. So notice how the parameters and return values are declared in the prototype. The interesting difference between them here is that when you are declaring a function, you just need to write the type of the input. You didn't write y. So you know that there is going to be an integer that's going to be input. You don't know what that integer value will be stored in. You don't know the variable in which it is stored. You just know that there is one variable as an input and it is of type integer, and there is one variable as an output and it is also of type integer. That's it. Here you know that the input variable, whatever it is, it will be stored in another variable, a local variable to this, which is called y. So you don't need to write y here. If you write, that's fine, but you don't need to write it. Whereas in the actual function definition, you must write the variable name here, because you need to store the value and do the local operations from there. X, remember, is if I can take you back here, we had the variable x in main. This is a different block. This is a different block. If you try to access x over here in this function, you cannot do that. If you try to access y in this function, you cannot do that. This y is a local variable to this block, and this x is a local variable to this block. Cannot access x over here, cannot access y over here. So you have to pass them, and the values will be copied just as we saw over here. This is where the function is called, and this is where the function is actually defined. So you give a prototype, you just make a mention that there is going to be a function called square, takes one input of type integer, returns an output of type integer. You can use it, and when you actually use it, then it's going to go looking where that function is, and it will find it over here. So the function prototype must have a function name. It must have the parameters, the information the function takes in, and a return type. If you don't, it will have a default return type of int. If you don't want the function to return anything, then you must signify that by using the keyword void. So void means, for instance, if instead of returning the square, I just want to calculate the square and just write it. So I would write void and square int y. Now this function takes a value of type integer named y, but doesn't return anything. So as an example, it could be simply cout y into y. So I don't have to put return anything because there is no return. In fact, if I put a return, it will give me an error. It will say that here you say it is void and here you're trying to return something. So no return, not even return 0, no return over here, because you're telling the compiler, the software, that this function does not return anything. It is void. So there is not going to be any return. And in the main, you can simply int main and simply write square 100, return 0. Why return 0? Because this main does has a return type. So here in this case, when you execute this, of course this will come over here, or you can have a prototype and then give the definition below the main one and the same thing. So in this case, you will have a square 100. There is no return. It's not expecting any return. There is no cout. There is no variable to store here. It's just calling this function square and passing the value 100. So when you pass this over 100, then y will become 100. Y into y, 100 into 100, that will be 10,000. So the cout here will be 10,000, and that's it. It will cout and it won't return anything. And you can see here there is no cout statement from where this is being called, and there is no variable to which this is being assigned. So for instance, as an example, you have so we're discussing function prototypes. Int max int int int, it means that this function, we don't even know the definition here, but because of the name and the data types, we can make a guess that this is a function that will intake 3 values and return the maximum of the 3 values. So takes in 3 integer values and return an integer which is the maximum of the 3 values. So note that it is enough to mention the data type of the input in the function prototype. You don't have to write int x, int y, int z, or a, b, c, or whatever variables you have. You just need to, at the prototype level, you just need to write what the data types will be without going into the variables. However, when you come to the definition of this function, then you will, at that point, you will have to write int x, int y, and int z, or whatever variables you want. It could be a, b, c, it could be e, f, g, or anything you like. So here is the example of that function. So we have int maximum, int int. This is the function prototype. It means that you're telling the software there is going to be a function called maximum. It will take 3 inputs. All 3 inputs will be of type integer, and the function is going to return a value which is also of type integer. So here you have int a, b, c. This is the main function. You ask the user to enter what the values of a, b, c they want it to be. So it will see in a, b, and c. You have 3 inputs. So the first input will be in a, the second in b, and the third one in c. And then you write cout, the maximum is, and max a, b, c. Now you can see here that this is in a cout. So it means that it is expecting something to be returned, which will then be cout here. So that's the end of the main. You have the function declaration over here. So somewhere there's going to be definition. This is the definition of the function. It comes after the main, and here you will have to write x, y, and z, the name of the variables where this a, b, c will be stored. So a will be stored in x, b will be stored in y, and c will be stored in z, because this is the order in which you send them, and this is the order in which you receive them. So a goes to x, b goes to y, c goes to z. So the first in the first, the second in the second, and the third in the third, in that order. And this is basically the operations of, or the working of the function. So you define a local variable. These 3 x, y, and z were the parameters. Max here is a local variable. So you define max as the first one. You assume the first one is the maximum, and then you check whether it is, compare it with the second and the third, and if it is not the maximum, then you replace it. But the idea here is that you assume that the first one is the maximum, and then you check with this one. If it is not the maximum, then you take this as the maximum, and then you check with this, and if it's not the maximum, you replace it. If it is, then you keep whatever value you had. So if I write, for instance, if the main sends a is equal to 10, b is equal to 12, and c is equal to 8. So here x, the value of a goes to x, so x will be 10. This y is equal to, so you have over here 12, and z equal to, here you have 8. So you're assuming the first one, that is x is the maximum. So you, at the beginning, you're assuming that this value 10 here is the maximum, and now you're going to check if y is greater than max. So this is y. Y means 12 is greater than 10. Yes, it is greater than 10. So the max is now updated and is equal to y. So instead of this, we have max now equal to y, and y is 12. And then you check if z is greater than max, so the value of z here is 8, and you check whether this 8 is greater than, now the updated value of max is 12, so is 8 greater than 12? No, so this won't be executed. So this will be executed, this will be true, this will be false, and therefore this won't be executed, and therefore you return max, and it means the return value will be 12. This is what you're going to return, and once you return that, it means that this entire statement over here will be replaced by the value 12. So simply you are going to, is as good as saying that you are going to write cout maximum is 12, because that's what this function will evaluate to become. So this entire function definition here is replaced by the value of the return, which is 12. So this is as good as saying cout maximum is 12. And oops. So you can have something over here, or we can just cancel that. So maximum, these are the three sample outputs. So if the user enters 22, 85 and 17, the max is here 85, and if you enter this, the max is 92. If you enter this, the max is 98. So this is how a basic function works. So the initial max value, and then here you are looking to replace the value only if it is greater, but otherwise just keep it as it is. So we'll stop here and we'll continue with this header files in the next lecture. The way this is going to be is that I'm going to record such videos, and then I'm going to upload that either directly in your Teams or upload it on YouTube, and then put a link in the MS Team for this course. And that's how the first lecture will be, and in the next lecture we'll have an interactive session. So it means that you all have to log into the team software, and then we'll have a direct interactive conversation. We can discuss this, or if you have any questions or answers, or we can look at some few more examples. But I do expect that you will have watched this video before the next class. So we have two classes, one is on Tuesday and the next is on Thursday. So what I will do is that I will upload the video on Tuesday. So I'll send a link to the channel automatically on Tuesday morning. The video will be uploaded, you will be able to watch that video, and in the Thursday class I will ask you these questions from the video. And if you have any questions from the video, you can ask me, and in whatever the remainder time we have, we can discuss new examples for this. So the attendance policy is also going to be intact for the interactive session. Will take, so whenever you log in, with the Microsoft Teams provides an automatic system where I can download the attendance, and so all the people that are currently online I will be able to see them. So maybe within 5 minutes I will just click that download, and whoever is online during that time, they will be marked present, and if you're not online, then you will be marked absent. So make sure that at least in the interactive session you are online, and if there is any problem, you should communicate to me at least one day before. So if you have any questions, any comments, any ways you think that we can improve this course, please do send me a post on the MS Team, or let me know during the interactive session. So with that, I'll stop here. Thank you for watching the video.